Hello, I got this 250 size carbon fiber quadcopter frame a while ago, and I've been waiting for some other parts to arrive for it before I put it together. So everything's here now, so I'm going to put it together, and I thought I'd just take a little bit of video as I'm putting it together and just give my thoughts on the frame and just sort of random comments really as I go through it. So this is not really a build video or an unboxing or a how-to or a review or anything like that, but it will have, I guess, elements of each of those kind of things. Mainly it's going to be a build video, and yeah, so I have everything here together like I say, and this is not a cheap-ass style build as you may be used to if you've seen some of my other videos. I am going to recycle the motors and the ESCs from this quadcopter that I've been using for the last few months. But the rest of the stuff is going to be brand new, and I'm going to be using the Flip 32, which is a NAZ 32 flight controller really, and I'm going to be using CleanFlight for that because I've been looking at the CleanFlight source code a little bit lately, and I managed to build my own CleanFlight hex and install that onto the flight controller, so I'll probably find myself playing around with the CleanFlight source code a bit in the future. So yeah, mainly this video is going to focus on this frame and how it performs, I guess. So yeah, it's not an unboxing. Obviously I've already unboxed it, although I will just show you what else was in the box apart from what is here. So it's just a typical design, kind of like the blackout frame really, as far as I understand it. There's three plates in the middle and then the four arms, and the arms are 3mm carbon fiber. The top and the bottom plates here are 2mm, I think, and then the one in the middle is 1mm. It seems to be fairly decent quality milling and carbon fiber. I don't know a whole lot about carbon fiber really. This is the first frame I've had that is actually carbon fiber. So if you want to know a little bit about how problems can arise with poor quality milling, and this is only a $30-something frame, so that's probably one thing that people will be wondering when they're looking at buying a frame like this, what kind of quality is the construction of it. And like I say, from my limited experience, I can't really see a whole lot wrong with it. It looks to be fairly good quality. The problems that you can get is if the machine head that does the milling is a little bit worn, the edges can be rough and so on. I haven't seen that anywhere much except for just on this piece here. If we can focus other side, so you can see on the inside of the circular piece there's some little bit of some chunks sort of out of the edge on the inside circle there, but nothing major, and there's nothing on that side, so I guess the tool was coming in from this side. So yeah, apart from those pieces, we also got a Mobius plate and some carbon fiber feet, which I don't think I'll be bothering with. 10 of these rubber damping balls to mount the Mobius plate with. Some of these little things to go inside the damping balls, and they're just a plastic. Not sure if I'll use these, but the idea is it's just a plastic screw that goes in and has a plate on each end so that the ball can't be pulled apart in a crash. That's the idea. Might as well use them, I suppose. What else? We've got two sets of props. The Diatone props. Not the greatest props, but I guess if you're getting them for free, not complaining. We also had a spare of, I think there's a couple of spare screws and a couple of spare nuts for everything. They give you an Allen key to use for the hex nuts there, and they also give you one spare of these aluminium spacers, which is great because they are, as I found out with my other Diatone frame, they're quite easy to break just by tightening the nuts too tight. So that's my first tip, I guess. Just don't tighten them up too tight, and go with some Loctite or something instead of tightening them too much. Right, so let's put all this stuff away. Oh, and I set up another spreadsheet here, which I will put a link to in the description. So the stuff that I'm going to use here is totaling up to $160 for just the basics, so that's just to get the thing flying. And that's all coming from Banggood except for the ESCs, which came from Hobby King. And I will be adding this stuff as well, excuse me, and that's about $25 to get some FPV gear with a rubber duck antenna, and then $32 or another $20 if you want GPS on there. And I thought I'd throw this receiver in here that I got as well. So I'll have a look at all these parts in a second, but the total of everything that I'm going to put on this particular build is $220 or so. There'll be a little bit more because the Hobby King ESCs will require some shipping. Banggood, of course, doesn't require any shipping costs, so it'll be $220 plus the shipping for the Hobby King stuff if you're looking at getting this kind of setup. Alright, so the frame is this one here, and that's $32 at the moment. Pretty decent price, I think. And I also got this because I quite like the idea of being able to solder the ESCs directly onto the bottom plate of the frame. So this is actually what I was waiting for to arrive before I started my build. So this just arrived today, so that's why I'm starting this now. As well as keeping everything nice and tidy, this gives you there's a couple of little places on here where you can solder in these little LED strips like that. Those are also Diatone ones, just $1.50 for those. Okay, so this is the flight controller I'm going to use. $24 for the Flip 32. Originally I was going to get the official, shall we say, Naze 32 board because the Acro Naze 32 with just without the barometer and the compass is $25, and this is $24. So I thought, well, I'll just spend the extra dollar and get it from get the original, support the original, the guy, and so on. But then I realized that this one is actually not the basic one. This includes the compass and the MS5611 barometer. So in that case, it becomes a no-brainer because the Naze 32 that has all the sensors on it is $50. So obviously I'm going to get that one. And I really like this so far. I've just been playing around with it in the with the CleanFlight software, as I say, trying and flashing it and stuff and setting things up. And yeah, it's really great so far. Right, ESCs are these ones, and they're about $8 each. And I got these from Hobby King because these were recommended to be reliable to work with the Sunny Sky X2204 motors that I'm using. I had a lot of trouble with my previous ESCs. They would run fine on 2S, but they would cut out very quickly on 3S just because the ESCs weren't syncing properly with the motors and so on. I'm sure you could find, if you wanted to get everything on Banggood, I'm sure you could find something on Banggood that would be okay, but I haven't really looked around too much. Which brings me to the motors. Now, I made a video a while ago complaining about getting a fake motor from Banggood. One of these was a fake. So I'm not recommending this wholeheartedly, but for this price it's worth a try, and I have got good ones in the past. I got a set of 4 good ones last year. I got another set of 4 good ones, the 2208s, just a couple of months ago that were good. So it's just a matter of time. If you want to waste some time waiting for a shipment that turns out to be fake motors, Banggood will refund your money, but you've wasted your time basically. So for me, most stuff ships to me from Banggood in about 10 days, so I don't worry too much about taking a gamble on a cheap motor like that. Anyway, so that's the motors that I'll be using. I also put this into my price list, although I'll actually be just making one up myself from some spares that I have lying around. And this is the LED lights that will fit onto the bottom of the PDB if you have that board. I won't go into too much detail about the camera and stuff, but these are the ones I'm going to be using. I'm not going to do this in today's video, but I'll put them on later. And this is the GPS, and this is the receiver that I'll be using. So anyway, I'll put a link to this sheet in the video description. Now, just before I get to dismantling this, somebody asked me if I could show a little bit about how I put this together. Okay, so what we have in here is another NAS F32. This is an official NAS F32, the Afro Mini, very small version. Let me just unplug these. So the ESC's control signal wires to the ESC's going in there. So I just have a orange RX that is a R410X receiver, and that only has 4 channels if you're using PWM outputs. As you can see there's just rudder, elevator, aileron and throttle. However, it does have 6 channels if you're using PPM, which is what I'm doing. So you can see the white wire there is taking the PPM signal over to the PPM input on the NAS F32, and then the red and the black are of course just the ground and 5 volts to power it. So this is extremely compact. So that's the receiver and the flight controller together there in around about the same size, or actually quite a bit smaller than the normal NAS F32, or 3 centimeter size board. Now the drawbacks though, of course, where I have it, the antennas are inside and they're directly above the power board and everything, and then I shoved my video transmitter stuff on top, so I wasn't getting very good signal after about 120 meters or so. So that's another reason I wanted to rearrange this build, because I had a few crashes just from the radio control dropping out, and so that's how I broke this base plate there. And the base plate was just covering up this section, and on the bottom there I have just a simple power distribution board which includes a voltage step down regulator on it there. There's actually 2 of them, one's 5 volts and one's 12 volts, and I'm just using the 5 volt one to power the so that's going through to the top there to power the receiver and the flight controller. And this one here was going to my video transmitter like that, so this just stuck onto the top like that, and I have the video camera cable at the front here, and that was just plugging into this little camera at the front. So that's all that was. So let's look back at this frame, and I'll just point out a couple of things that I didn't like so much. And one is the narrowness of these pillars here, because what I kind of wanted to do was use this FPV camera, this tiny little one on the front there, which is just mounted on with some hot glue and a piece of wood with a notch cut out of it to hold it in the right place. But that camera is really good, and I actually like it more than this camera, even though this camera is this is 700 TV lines camera, this is 600. But this one has a lot better response to the situation where quite often you can get a scene where the sky, at the top of the screen, the sky is very bright and then the ground is darker. And this camera here, I found it blacks out the ground a lot, so you can't really see very well in that situation, whereas this little camera here does a lot better at keeping the brightness. It just makes things a lot easier to see. So I wanted to use this one, which would only take up a little bit of space there, and I thought, wouldn't it be great if I could put my Mobius inside? But with the spacing of these pillars, it's just not going to happen, and so you can see it's not going to get in there, and likewise it's not even going to fit in there either. So it's a little bit naughty of me to already be thinking about my next build as I'm not even started on this one. But it would be nice to have a frame like this, except just a bit bigger, maybe a 330 size or something, where you could put the Mobius inside there, and also perhaps even the battery, because that's another thing I thought. Of course, once you put your video gear in, there's no space for a battery, but let's say if you didn't have video gear, you could put your battery in there, but it's not even wide enough for this 3-cell battery to fit in there, which is a pity because it's perfectly spaced height-wise. See, that's quite nice. Another thing I probably should have mentioned earlier, the holes on the top here are made, of course, for that Mobius damping balls mount plate to go, and you can put that at either end. And there's another hole just here which is quite convenient to fit your video transmitter aerial and antenna plug in there, I think. So most people will probably have a plug like this that's going to go in there, and that fits in there just nicely. Although it's a little bit large, and it does fit into either of any of these other holes as well if you want to put it somewhere else. But it's a little bit large, that hole, and I found that when you put the nut on like that, it's not focusing. Oh, there we go. This nut, while it does fit, is a little bit, the hole is a little bit too large, so I don't think it would be a very comfortable fit with just the nut. So you'd need, at least I'm going to try doing it with a washer like this. So if you have a washer like that, I think it would be okay. That just takes up that little bit of space quite nicely. So yeah, just something I noticed. Alright, well, I think I'll get started in putting this together then. Not too much else. Oh yeah, another thing I didn't think was very user friendly was the way that those pillars at the front are directly in front of the screws that are used to mount the camera into that plate there. You see what I mean? Because it would be nice if you could just come at it with a screwdriver from the front like this and unscrew those to maybe take the camera out without taking the plate itself out, because unfortunately if I wanted to get this camera out now, I have to undo these two plates and this one, sorry, these two nut screws here and those two, and then sort of bend the carbon fiber plate of the top up a little bit to sort of squeeze the plate out. Yeah, so that's a bit of a bummer. But otherwise it all fits in there quite securely. It's nice and tight, doesn't wobble around or anything. Oh, just one more thing that I remembered. This is something else that I saw in one of Bruce Simpson's videos where he managed to break the end of the arm off, and he was talking about the way that the carbon fiber is made too thin at this area, and this at first glance might seem to be a prime candidate for that kind of problem, because it does get very thin there at the at that edge there where the holes are sort of jutting out a little bit in the edge. But I don't think it's going to be so much of a problem, because the area where it gets thin is here, and the motor itself is going to be bolted on here, so the motor being there should supply a little bit of strength to that area. So I'm hoping it's not going to have the problems where it breaks off here. More importantly than that though, the sizing of these holes is kind of annoying, because most often motors that we use are going to be like this, at least for non-micro size motors. Like the motors that have 16mm and 19mm holes are going to be like this, and they're arranged in a standard positioning like that. And as you can see here, the set of holes that are like at a cross position are too small for this motor to fit in. So this motor is going to have to use the motors that are in a plus position like that, so like that and like that. And unfortunately that's going to leave the motor wires sticking out like that at a 45-degree angle. So what we really want to do is put it like that, but we can't. So that's something that I think is not really a great design. Would have been nicer if they had have perhaps just made the arms a little bit wider and made all of these holes wide enough to fit the 19mm screws in. So we're just going to have to put it like that and kind of make the wires go down the edge of the arm on top of it like that, I guess. Anyway, I'll see what happens when I get to it. Oh, while I'm here though, I should have also mentioned this earlier. Amazing how I remember everything as soon as I say I'm done. You can fit, it seems, 6-inch props on here, although it's going to be really, really tight. So that's a 6-inch prop there, and it's about 2mm away from the aluminium standoff at this point. Should be okay. And just to be safe, we'll check that way as well. Yeah, that's no problem. Okay, this is totally, well, not totally, but almost entirely irrelevant to the rest of the video, but I just thought I'd mention, just in case, on the off chance that it helps somebody, be careful when you're unsoldering things like this, because what I was just doing now is focus. So I was unsoldering the connections between these, the motors and the SCs. So to do that, the natural way to do it is probably to pull on this wire a little bit as you're heating it up. But the problem with that is that when the solder bond breaks free, this other side of the wire, or even this side maybe, tends to flick a little bit. And I got a splash of solder right on the corner of my eye. So I was quite lucky not to get it in the eye, I suppose. So I'll be wearing some eye protection for the rest of this procedure. Either that, or you could find a way to make it so that this side of the wire was held steady instead of being free to flick when it released. For mounting the motors onto the arms, I'm not really a big fan of having this hard carbon fiber surface pressed directly against the hard steel surface of the motor like that, without having any sort of a compressible thing in between them. So I'm going to use a little bit of this 0.5 mm thick rubber sheet, and I'm just going to put that in between them like that. And I suppose it might reduce the vibrations a little bit, but it's not really the point. The point is just so that when the screws are tightened in there, they're sort of held in there as like a spring washer sort of situation. It probably doesn't really matter. You could perhaps use Loctite and be safe, but it can't hurt, so I'm going to do that. Well, there is one of them made. So it's just a very thin piece of rubber underneath the motor. And it feels really good. It feels really solid and secure. And yeah, I like it. However, it took a long time to make, so I'm not sure if I have the patience to continue and make another 4 of them right now. I'll think about that. Well, I did go ahead and do that after all for each motor. It just feels so nice and snug when you're tightening the screw in to have that rubber in between there. It tightens it down. It feels really good. Fuck!
You can literally apply, as a professional, you can literally apply everything ever.
Well, that's how not to do it, I guess. Well, I was just having another look at the product listing for this PDB, and I didn't notice anything mentioned at the time, but it seems that you're not supposed to use this with the carbon fiber version of this frame, and there is actually a fiberglass version of this frame as well. And in the comments here, I notice now that I actually look at them, this guy says, blah blah blah, you will get fire, and he's exactly right, isn't he? So because carbon fiber conducts electricity, that's the reason you don't receive this PDB with the carbon fiber version. Alright, well that's the answer. So I'm just going to revert back from using this. I'm going to have to take this off and unfortunately go back to using the plain old carbon fiber only sheet in the middle. But I do have a little PDB that will fit in here quite nicely. This is quite a nice little one. It's the same hole spacing and everything as the Flip 32 and the CC3D and everything. Because this is now not allowed to touch onto the base plate there because it's conductive. So instead of using the rubber grommets, I'm going to use this fiberglass mounting panel, because that also fits onto the 3cm holes exactly, and the whole thing is about 1 millimeter, maybe 2 millimeters in height. So that should keep it isolated electrically, but with the minimum height wastage. Unfortunately, I've struck a bit of a roadblock here. This ESC has been damaged. When I was removing the old wires from it here, somehow I managed to lift this pad off the PCB. I don't know if you can see it there, but it's lifted away from the board, and even though it still seems to be attached to it, it's not functioning correctly, because when I try to spin up the motor, it sort of shudders and shakes and doesn't really spin. And since it seemed like it was pretty stuffed anyway, I thought I'd, just on the off chance that connecting this solder blob to the right hand side of this regulator, or whatever this thing is here, I just thought perhaps if I just connected that to there, it might be the connection that it's needing. But unfortunately that gave me some magic smoke. So this ESC is now unfortunately toast, and I'm going to have to buy some more, or one more at least, before I can continue. So not too expensive, but it'll take a few days for it to get here. So unfortunately that is as far as I'm going to get with this for the time being. I think I'll upload this video anyway because it's getting kind of long, and I'll continue with it when I get the other ESC. But in the meantime, just before I finish, I thought I'd investigate a little bit more exactly what happened with this board. And it turns out that the board itself is probably still usable. So if I had the fiberglass frame, I could still go ahead and use it. And I had an idea that may make it even possible to use with the carbon fiber frame still. But anyway, let's have a look at what happened. So this is the screw hole that got damaged the most, and you can see there's a copper trace inside this board, very, very close to that hole. It's probably less than 1 millimeter away from the edge of the hole there, so not much space at all. And also on the underside it's the same. Well, okay, there we go. So yeah, the problem seems like this board is not really designed that well, because that copper trace, I don't think it should be so close, because the problem is, we just look at a hole that is not yet damaged. For example, let's see if we can focus on this. So there's kind of a paint or a lacquer coating or something on there, so there's no conductivity. But the problem with the copper trace being so close is that when you put a screw head in there and you turn the screw around, this screw is actually, the screw head is wide enough to touch the copper trace, so it wears it down a little bit until you get to a situation like, this probably doesn't show up too well in the video, but this one here, for example, you can see, maybe you can see that the edge of the screw hole, the copper is actually showing there on this one. Doesn't show up very well in the video, I'm sorry, but to look at this in person, you can see that there's actually bare copper on around the edge of there. So I think what's happened is this one here was also kind of like that state, and the screw was conducting from this side, which is positive, through to, on the back here there was the nut, which was touching onto the carbon fiber, and then the carbon fiber plate on the bottom, I guess, would have been, oh sorry, this is the top and that's the bottom, whatever. Anyway, the carbon fiber plate on the bottom would then be conducting that through to the negative terminal of the battery. And the result of that, as we can see from this still frame that I got from the video, is that the whole screw and the nut together heated up until they were red hot like that, and then the heat just ended up burning out and delaminating one side of this the arm of the carbon fiber that was in the middle of them. Fortunately, the other side was not delaminated, it was quite clean still, so the arm is still in pretty good shape. But I was looking around at this is the blackout frame, and you can just sort of faintly see the copper trace around the screws here, and look how far away it is from those screws. It's nowhere near them. So even if you had a screw head that was like 1.5 times the size of this, it's still not going to be touching the copper traces there. So this is a good design, and I think the board that I have here is not such a good design. However, to get around that, one idea I had, because this board itself doesn't seem to have been, like, there's no short there now, otherwise I wouldn't be able to do this, because the current wouldn't go through those LEDs, it would just go through the short. So I think this board is, apart from the ugly looking piece here, it's not actually damaged beyond use. So what I thought might be possible to do is, if you could get an electrically insulating washer like this to put over these holes so that the screw head did not scrape off that paint, you could probably still use it as is, even with the carbon fiber frame. However, I wouldn't use this because this is just plastic, and you need to be tightening these screws and nuts together pretty tight to hold the arms on. So I think this plastic would just get crushed pretty quick, especially if you had a crash, and then yeah you'd be back where you started again. But if you could get something that wouldn't be crushed so easy, like maybe this thin glass fiber sort of sheet, and this is about 0.5 millimeter thick. If you could get something like that to be a washer that's not going to be crushed so easy, then I think you might still be able to use this PCB with the carbon fiber frame even. But for me, I think it's just tempting fate a little bit too much, so I'm going to go ahead with using the PDB under there like that. That's not too bad. It'll make things a little bit heavier and a little bit messier, but hopefully not catching on fire. Anyway, this is to be continued.